Okay, welcome back, everybody. We're on to week 6, and this week we're going to start talking about access control, which is can be defined a couple different ways and include a whole lot of stuff. But in our discussions, we're going to really concentrate on access control in the electronic sense, because as you guys know, that locks and things like that are also access control. And we'll go over all the different types of access control elements in building security. But primarily this week, we're going to talk about electronic access control. And most people find this to be kind of cool stuff. If you have trouble understanding it, there's some technical stuff in here, right? If you're not a wiring person or a technical person, listen really carefully. And if you don't get it, call me and I'll talk you through it, because sometimes it's just easier one-on-one to explain stuff. So I don't mind doing that at all. First, let's start with a couple of housekeeping issues, though. Okay, those of you who read the news items that pop up in the course, I know some of you don't, because some have already missed an extra credit opportunity that closed out a few weeks ago, and some of you took advantage of it, probably just a small handful actually. But if you read the news articles, you know that I went on this week about due dates. And due dates are firm going forward, unless you are excused by me at least 24 hours before the due date of an assignment. Then expect that you will get a 0 on the assignment. If it is a discussion and you miss the Thursday, our discussions are always due. The initial post on Thursdays at midnight, 11:59 rather, on Thursday, and then the responses are due Sunday at 11:59. It's not rocket science. I've been doing it this way for a while, and it's been that same pattern. If you don't have the Thursday 11:59 in, don't bother doing the Sunday, because you're going to get a 0 on the whole thing. Those of you who have had me before know I try to be easygoing, but if you can't keep up with those simple deadlines, then I think you might want to think about whether you want to stay in the course or not. I don't encourage anybody to ever drop a course that I take. In fact, those who have tried always end up getting a phone call from me talking about the pros and cons. But if you can't hold up your end of the bargain, then that may be the best bet. We're getting in that sleepy time in the semester, right? Where things are starting to drag. People are starting to get tired. The newness of the new semester is done, and now you're kind of in the middle of it. Some of you, upperclassmen, are thinking about internships and summer jobs and all that stuff. Don't take your eye off the prize, okay? You really need to get through your semester with good grades and good learning. So, try to keep your motivation up. If I can help you in any way on that, please let me know. The discussion this week, and I'll go over it again at the end of the lecture, but it's going to be to turn in a preliminary drawing of the lock choices for our warehouse. In the D2L shell, there is the drawing for the internal floor plan of our warehouse. In the discussion, I give some special instructions on how I want that laid out, and also some new information about the use of the warehouse. And your assignment this week is to do that and to submit those drawings in the discussion board in a scanned copy. If you can scan it and then have it so it shows up where people don't have to open extra files, that is much preferred. So if you could scan something and then either drag it in or have it so that it's automatically open when we open your discussion, that is the preferred method. So we'll go over that a bit at the end. Let's start talking about access control. So you'll hear people in the security industry talk about access control, and they're almost always talking about electronic access systems. But access control, if you think about the standard definition of it, it's anything. It's a system or an item or any element that ensures only authorized people enter a controlled area. So a key lock is actually access control, right? You give the key to the person who should be able to get in. They use their key to get in legally. The access has been controlled in some way. Guards stopping people checking an ID. Only people with IDs can get beyond point A. That's access control. Receptionists, same way, right? A receptionist greets you at the door, and if you don't belong there, they turn you away. They are controlling access to your building. And signage can be, a keep out, do not enter sign. It's very limited because it doesn't, there's no real stoppage there. But it does control access in some way, because you at least know that those who have passed by that do not enter sign and still entered, at least you know they are there with ill intent, or at least of their own volition. And so that's a type of access control. But then, of course, there's electronic access control systems, which is really where we're going to concentrate our discussion on access control. So you will hear me say access control, normally discussing electronic systems too. But I just wanted to call to your attention that it's not the only option and it's not the only definition. Most people in our field will talk about it that way, but don't take your eye off the fact that there are other ways to control access to buildings. The more common definition, and the one that we'll kind of use for our definition, is an access control system is an electronic system of credentials, locks, and other devices that allow or deny access to people to controlled areas. An access system will record entry and denial activity for future review by authorized administrators. So it's basically something that's electronic, that opens and closes doors, and keeps a history of that so you can go back later and see who went and who came and left. Pretty simple stuff. Those of you who have lived in the dorms likely have a card access system on either your room or entry into the building. But you probably haven't given much thought other than the fact that you insert or wave your card and you got in your room. But there's a lot of working parts to these, and so we'll go over those in this particular unit and hopefully give you a better understanding of how they work and the different components and how they all fit together. So what makes an electronic access system unique? Well, selective entry. The keys are individualized, right? If you're using a card, and most access control systems today still use a card, and there are others, and we'll talk about those, but most of them still use an ID card, right? An access card. And it can be selective. So not every card is going to work. It makes a historical record. That is an important feature in an access control system. There are some systems out there where you insert your card and it doesn't record anything. It just opens and closes it. That's not a true access control system in the sense that we use it, because that historical record is a very important feature of a commercial access control system. Now you can integrate your access control system with all kinds of stuff. When that badge runs to that reader and it opens the door, you can use that input, right? Something happened. If the card opens the door, turn the camera on and take a picture of who's going in the door. If you run the badge and the person isn't allowed to go in, cause an alarm to go off somewhere. A silent alarm, some kind of a notice to somebody saying, hey, this person's trying to get in and they're not supposed to. They can be integrated, which is an important feature, different than a lock. It's normally very hard to integrate a lock and a key to anything other than the lock and the key. Now, there are no keys, sort of, because your badge is essentially a type of key, and there are others, there's fobs and other things that we'll look at. But for the most part, there are no real keys. You do have the ability to turn off access remotely without personal contact. So if we have an access control in the standard definition of a key and a door, in order to keep you out, I have to get that key back from you, or I have to change the lock. With an access control system, I can turn it on and off. So the system makes the decision. So when you present that badge that worked yesterday, it may not work today because I turn it off at the opposite end. It isn't controlled by the end of the device that's at the door. It's controlled by a head end off someplace else. Okay? And you can use the data from these for other purposes. And we'll talk about a few of those. So if access control systems, they keep a history and you can turn them off remotely, why would you use keys at all? Why wouldn't you just put them on every door? Well, the big reason is cost. It will normally cost between $5,000 and $10,000 per door for a fully wired access control system. Now, I say that in the university, it was probably about $1,000 per door if every room entry has its own card access reader on it. Then it was probably less. Why? Because they can be daisy-chained together. But that initial installation of the backbone, all the wiring that goes through that runs down to each one of those doors, certainly when you take the cost of running all that wiring, the locking devices, the readers themselves, the badge issuance, they are not cheap compared to a door lock. And in an industrial setting, if you have a door that has a key and a lock on it, you say, I want to put a card reader on this door, you can usually count on about $5,000 of modification to the door frame, to the electronics, to running wiring, to programming, all that sort of stuff that you need to do. It's going to be at least $5,000 worth of time and energy and cost. $10,000, depending on the area, because it could be more if you have concrete walls and you have to drill. If the door frame is steel versus wood, there's a lot of different variables here. But certainly they are not as cheap as a standard key lock. So when we go through and do our designs this week on our locks internal to our building, we want to be cognizant of the fact that we could put a card reader on every room in the building, and it would be pretty slick. But when I give you a budget in week 13 or week 12, somewhere around there, and say, make sure you're staying under this new budget number we just got, you're going to be really disappointed if you try to do that. So you have to use these things judiciously. There is administration and maintenance. So you put a key lock on a door, and think about the key lock on the front door of your apartment or your home. I mean, how often does anybody maintain that? I mean, once a year, if you're really good at it, you put a little bit of, lock lubricant in the thing so that it works easier. And you clean around the receiver and the bolt and put a little bit more lubricant there so everything runs smoothly and doesn't wear out. But locks on doors especially on home doors, are not commercial locks. And they don't take nearly the use that a commercial lock does. And so they last for 30, 40, 50 years sometimes. In fact, you will find on many old homes in the U.S. something called Yale No. 1 lock. It is a type of deadbolt lock, actually, and they were made with a common key. The locksmith who put them on, or the builder, was supposed to change the key on them, but normally they took them out of the box, put them up, and hand you the key. And it's kind of funny, people don't understand that many of these locks on older homes have the exact same key. But with an electronic access control system, there's maintenance. I mean, there are a lot of moving electronic parts. Electronic parts wear out. Electronic parts burn out. Electronic parts become obsolete. They run off a computer, and operating systems change. And someone has to administer them. Someone has to turn on and off the access to areas and keep track of who has badges and who does not. So there's complexity to them. You normally need to make a permanent modification. When we looked at the locks last week, we saw that on electric strike, you have to actually cut part of the door frame out. Even with a mag lock, you still have to drill into the door frame to mount the magnet and or the receiver for the magnet if it's not a metal door, right? You need the plate. So you've got to make some permanent modification, unlike a door that is, a standard door that has a core in it where you put your lock in, the doorknob and the lock, right? It comes that way from the factory. You normally have to permanently modify the door end or door frame and sometimes other things to put in an electronic system. So there's a complexity and a cost there. And of course, it requires power and normally network access. So you can do that wirelessly, right? We all use wireless on our computers to connect to the internet these days. But many access control systems are hardwired so that you don't interfere with, no one can hack into the system really if it's on a closed backbone of sorts and it's on wires. So you definitely need to have power to operate the door, power for the reader to accept the signals, power to go back to make the decision as to whether to open the door or not. And so if you don't have power immediately at the door, there's just another cost of putting something in. So you're not going to use these access control systems everywhere. You're going to use them where they're necessary, and in other places where they're not, you're going to use a regular lock and key. So what makes up an electronic access control system? Well, there's a credential. In our case, what we're going to use for our example, before we discuss any others, is a badge, right? An ID badge. The thing that you put up to the reader, the thing that reads the signal, right? There's a controller, and that is a field-based panel somewhere buried, usually in the ceiling or the wall, where the decision is made to open or close the door. Controllers normally control a certain number of doors, and they go back to a host, which is a server or a computer where all the central information is dumped in by your system administrator. And then you have all of the at-door stuff. You have a power supply, you have a request to exit device, which we'll talk about, and an electronic locking device, a mag lock or an electric strike. The credential then would be, in most cases, your badge, right? The reader would be the card reader, the badge reader, where you put the badge up to it and it then takes the information from the badge, reads it, deciphers it, sends it to a controller, which is a field-based panel. It's a box, and we'll look at some of them in just a second. Okay, goes back to a host, which is a server. And all these boxes in the field are connected to the server, and the server gives all of them information all the time to tell them what to do. And then you have the stuff on the door. So let's just look at a really basic drawing so we can look at the basic components here. Okay, So you need to watch now rather than just listen. Here is the host. And here's Brian sitting here, and he's putting in information. He's saying, okay, badge number 123 belongs to Bill Jones, and Bill is allowed to get into this door and this door and this door. Not that one. Bill can't get into this one. I put that information in. Bill is allowed. Here's Bill's badge number, 123. And badge number 123 will work in this door, and this door. Not door number 3. The host then sends that information to this control panel and that control panel. Same information. All the information goes down from the host and sits at the control panel. Bill walks up with his badge in hand. Here's the reader, and he runs his badge. He puts it up to the reader, and the reader goes back to that panel and says, is Bill allowed in this door? And the panel says, yes, he is, and it clicks this electric strike, and the door can open and Bill gets in. Same thing happens here. Bill goes to this door. He holds his reader badge up to this reader. The reader goes up to the panel and says, is Bill allowed in here? The panel says yes. It says, okay, great. Sends a signal down to unlock this door, and Bill goes through the door. Bill goes to this door, and he runs his badge, and up this line it goes to the panel, and it says, panel, is Bill allowed in this door? And the panel says, oh, hell no, we're not letting Bill in here. So it comes back down here to this signal and says, don't unlock. And the door does not unlock, and Bill can't get in. So all decisions are made really between the person holding up the badge being read, the information that's saying this is badge number 123, going to the control panel deciding whether or not it's a yes or a no, and deciding yes or no to unlock the door. Now, every so often, we put information in, right? Put in new information. Now, Bill, card 123, I'm also going to put in Mary, card 456. And every so often, usually about every few seconds, the host just keeps sending new information down and uploads information into the panel. So the host, very seldom is any information hooked to directly back to a host. There are some very small systems which will do that. But for the most part, can you imagine if you have a large system, how much information is trying to be processed at this location and how slow it might be getting down to these doors? Think about if you had a system the size of the one at Slippery Rock, or some of the ones I have in Pfizer where there are thousands of doors. I think, last count I had over 20,000 doors with a basic reader system like this. Can you imagine if 20,000 different people were trying to get in, how much traffic would be going here? With these panels, and these are called a 2-door control panel, right? The field panel, control panel. We're going to go with 2-door controllers for our projects, but they also come in flavors that do 4 and 8 and 16. But the 2-door is very common, and the reason for that is the distance. We'll talk about that in a second, but it's really simple. Badge to reader, goes to the control panel, which every so often gets new information sent to it by the host, and it makes a decision yes or no, and it tells the lock yes or no, open or don't open. Very simple stuff. So now we know the components and how they kind of interact. Let's talk about the credential itself. Now we talked about a card, a badge, right? There are many different types of credentials. An ID badge is probably the most common one, right? The ID badge can be printed on. It can have the face on it, lots of other stuff, right? There's good reasons to use a card. But some people also use a fob. Now a fob is just a little plastic, normally device, hangs from your keychain. They're very popular in places that have controlled parking, right? Where you come in and you just, hold up your fob and get in and out, right? Or you get close enough and it opens the gate for you, right? Some of them can read longer distance. But people like fobs because they can clip them onto sometimes their keychain, right? They can carry them in their pocket. They're about the same price as a badge, but they're not printable, right? They're just a little device. I'll show you a picture of one. Biodigital devices. Now, biodigital devices could be facial recognition, right? Instead of holding your badge up to the reader, it's a special type of reader with a camera built in that looks at your face and matches your face up and says, is this face a match, Mr. Control Panel? And it says yes or no because it's had the information on faces, digitized, of course, sent down from the host every once in a while, and lets you in the door. Or it could be a keypad. Sometimes it's a number, and you're just typing in a number, and that number is going back and it's saying, is this a valid number? Can I open this door? Very seldom we use keypads anymore all by themselves, but they are still out there. but the credential really should match the usage. There's an article this week for you to read on, how to select a credential. It's a commercial article, as many of them are for the course, and I apologize that, some of the best information is written by people who sell it, but that's the way it is. And I think this one kind of explains to you when and where you would use different types of credentials. For those who wanted to see a key fob, there's one right there. There are several different types, but it's just hooked onto your key, and you hold that up to the reader instead of the badge. Same inner workings. It just isn't used as an ID. The beauty of fobs, if you have a very small system, is you collect them back when you collect keys from people when they leave, and you can reissue the fob and put a new name on it. Where with an ID badge, you normally print directly to the badge, and when the person leaves, you cut it up and you have to have a new one. So they can be cost effective for small systems, but other than that, not much difference other than the history that they provide than a key. They can be handed off. Normally people don't hand off their ID badge very often in a commercial setting because they know it can get them into big trouble, and you can actually see that, right? If the person's badge doesn't match their face, there's a chance they'll get caught. With fobs, very little chance of getting caught and very low cost because you can reissue them, but you do lose that advantage. So that's just an example of a key fob that can be used. So in addition to that article, let's just talk a little bit about which credentials should you use. So a card can double as an ID, right? You use your ID card to check books out of the library, perhaps, to show somebody, university police, who you are. If they stop you on campus, they say, "Can I see your campus ID?" to make sure you belong. You can show it to them. It's a visual check, and they can see it, right? So it doubles as that. They're frequently lost. They are shareable, right? You could hand off one to another person, so you do have that vulnerability, but it's harder to hand them off because your face is plastered on it. And in most commercial settings, especially government settings, if you are found using somebody else's ID to access an area, it's pretty much a done deal. You will lose your job or be in some very serious trouble. So they are a very common credential. The fob that I showed you, no visual ID features, still very shareable, right? But they are reusable because you don't have to destroy them and make a new one. You can reissue, just take and change the name in the host as to who you issued them to, and then they will continue to work. Biodigital devices are never forgotten, right? They're the highest security ones. You can use your face. You can use hand geometry, which is the structure of the bones in the hand. High-speed fingerprint readers, I've used those just recently. You put all 5 fingerprints in, and very quickly it reads those fingerprints and decides who you are and whether you belong. They're never forgotten. They're the highest security. They are also extremely expensive. The actual card reader, when you use a badge, the card reader out of the box is about $200. That's not the installation cost and everything, right? That can go up to $5,000, like I said, but the actual, just the reader itself is usually around $200 for a proximity reader, the ones that you just hold the badge up to. For any type of biodigital device, I've never seen them less than $5,000 just for the device, be that iris scan or high speed fingerprint readers. They're all $5,000, $6,000, $7,000 each. So there's a big cost to those. And there's also privacy stigmas. You are collecting an awful lot of biometric data on people. You have some legal requirements to store that. We talk about that in my, in fact, the same week we discuss it under privacy laws in my corporate security law course. You're really putting a lot of onus on yourself to protect people's information when you start collecting fingerprints and iris scans and hand geometry, those things. And then keypads, they're easy, they're cheap. You don't have to give a hard credential. You're just giving out a number, and then people give that number to somebody else, and they're the lowest security, but again, they're still out there. You can go up, put in a number that's given to you, and that number says, okay, this number corresponds to Brian, and Brian is allowed in, so open the door. But you're never really guaranteed that it's me, and there's no way for me to really be caught if I give my number to somebody else, because nobody's going to watch my fingers as I put it in. So not a credential I would recommend, but you still will find them out there. So again, read the article for this week as part of the reading. It will give you some insight as to which credential you may want to use for our project and for future projects. For the most part, I would say that probably 95 or more % of access systems in the U.S. use an ID card type credential because it doubles as the ID. People are required to carry it. You have some visual cue as to whether the person who's carrying it is that person at all, and they're relatively inexpensive. Depending on the technology you get in it, they run between $3 and $7 each. So we talked about the credential. Now let's talk about the reader itself. So there are different types of readers, right? The one you use on campus is either probably a mag stripe reader, right? If there's a magnetic stripe on the back, a black stripe across the back of the badge, maybe that's it. Or it could be proximity. You just hold it up to the reader. It could be swipe, where you have to swipe it through a little track on the reader itself, or insert it into a door. Like there's a little slot on the door and you insert it in. There are tons of different kinds of readers. There are readers that read barcodes and QR codes, right? The little square codes that are kind of squiggly lines, right? You're all familiar with those, I'm sure. And you use those a lot for visitors. You issue the visitor a visitor badge to get in and out of your parts of your facility, and you put a barcode or a QR code reader, and you give them a visitor badge with a printed QR or barcode, and they'll hold it up to that reader. It will use optics to read it and open and close the door. The swipe reader is starting to go out of favor. It's the one where you actually insert it into the slot in the door or slide it through a slot on the reader itself, and it reads. And there's also the mag stripe ones that do the same thing. You swipe it through and it reads the information off the magnetic stripe on the back. Most common today, though, are the proximity card readers, where you just hold the badge up to the reader within about an inch or so. You can touch the reader. It's not going to hurt it, but usually within an inch to 2 inches it will read. There are some readers that are really big, and they will read from up to 2 feet away. You commonly use those in vehicle lanes where people pull up and it's raining outside and they hold their badge to the window and it will read a foot or two away from it on this big reader. But they're proximity. You only have to get close to the reader without touching it, and the reader itself is powered, the badge is not, and it's just the reader is using an antenna, a reader to read the antenna on the badge to give it information that's stored on the badge. There are powered cards out there, smart reader cards that are powered, and they do more things. You won't see them very often because it has a battery in it. Batteries wear out, and they're very expensive. The biodigital readers, again, they read fingerprints, retina scans, facial recognition, hand geometry, anything you can think of. One of my students last semester showed me a reader that actually tracks smell. A person has a unique odor about them. No matter what soaps or perfumes or colognes they have, there's a certain human fingerprint, if you will, right? I'll call it a fingerprint or a print of odor, and it will read that and identify a person. There are some that go with sound, certainly your voice. But the most common one, again, is that proximity. The big thing is the reader and the credential have to match. So you could not hold your proximity code, you couldn't hold a barcode up to a standard proximity reader because there's no optic on there to read it. You can't have a mag stripe reader and hold it up to a proximity because there's nothing to read the mag stripe. The credential and the reader, it's very important, have to match. One is going to be the thing that reads it. The other one's going to be the book it's reading, and they both need to be in the same language. So always make sure that your credential matches your reader. So here we're back to our diagram. Here is the reader. It's the first thing in the chain here, right? The person walks up with their badge, runs it here, goes to the control panel, which has been constantly getting new information as it's uploaded from the host, as people are typing in new information, making changes, even just polling it on a regular basis to make sure there's been no changes, keeps downloading stuff to these panels, and there's more panels as we go along with more doors. Every panel is getting updated every couple of seconds usually, and the reader goes to the panel and says yes or no, and it says yes, and it comes down here to here, and it unlocks the door. Easy stuff. So the field panel is an interesting thing, and people tend to forget about it, and it's the part that people don't see, so it's harder to understand. And the reason you have field panels is they give you intelligent control, right? Decisions are made there. The host is where you enter the information. The control panel is where the decisions are made using that information, and then the stuff downstream from there is where you enter the information that you want decided upon. It makes immediate allow or deny decisions. It stores both the history of who went in and out of the door on that panel, and it also stores the most recent card transactions. And there's a reason for that. So if I run my badge and it lets me in, that badge transaction is stored. And the reason it's stored is that if the host goes bad, if there's a connection broken from the host, my system will still work. It will still go back to that panel and say, yes, Brian's badge is okay to use because it's being stored here. That information is stored on board each one of the panels, and they can continue to make decisions. That's important if your internet goes down, if your network goes down, if your host computer crashes. if everything went back to the host, your entire facility, if that host crashed, would be locked down or unlocked, depending on how you have it set up, but there'd be no control. With the field panel, then if a field panel goes bad, only those doors connected to that panel may give you trouble. The rest of it will still work. So it's really an intermediate decision-making center that holds all the information that protects you from the vulnerability of your entire system shutting down. It sends the decision, the power, if you will, to the locking device. But the most important part of a field panel really is it's where the decisions are made. Again, I'm going to keep going over this because I want to make sure you understand it. The host is where you enter the information. It fields it to the field panel. That's where the information is stored. There's decisions being asked for from the reader, and it goes up. Decision is made by the field panel, and it sends its decision down to the door to lock or unlock. Control panel, hugely important. In our projects, we're going to use a 2-door controller. And the reason I say that is for every 2 doors that you have on your access control, if you decide on our warehouse to put card readers anyplace, for every 2 doors, you're going to need to have a panel. You're going to want those runs to be short, right? The wire runs between them to be relatively short. So you'll want to position your panels in the warehouse close to where the readers are if you can. Although our warehouse is not too big, so it shouldn't be a problem. But control panels are probably the most expensive part, besides the head-end software, right, where the host has software, and that software is always expensive, right, buying the system out of the box. You pay for that once. But the control panel is probably the most expensive part for good reason. It's the decision-making. It's the brains of the thing, really. And so when you start to put electronic access control in, if you put too many card readers in a building, for every 2 card readers at $5,000 a piece, let's just say by the time you get them wired and put together, the control panel itself is going to run you at least $10,000. You're adding now onto the cost. So not only is it the cost of that reader and modifying the door and everything, but for every 2 doors, you have to have one of these control panels to make the decision. You have to pay for those too. Another reason why you want to pick the right locking device for every room and door. If you don't need electronic access control, you don't use it. And if you do, you position it properly so that you try to use an even number with our 2-door controllers perhaps. But you want to understand that the cost of access control, electronic access control, can be very high, and especially when you start adding in the cost of these control panels, which are a necessary part of the operating system. Back to our simple diagram one more time. Here's the control panel. Information from the host comes down to each one of the control panels, right? Other control panels sitting out here. There's a dozen, 2 dozen, 100, depending on how big your system is, and they are connected to each individual door setup, right, for the reader and the door lock. There are other components here that we're going to talk about in a minute, but just remember, information gets put into the host, goes to the control panel. Requests are made at the door, decisions made at the panel, and they come down and lock or not unlock the door, and then they store that history of what they did and who they did it for, the badge they did it for, in here, so that if indeed this is broken right here, this line between the host and these panels, they continue to use that last information that Brian was allowed in the door. He's still allowed in the door. They use that last information to make the decisions that they don't need the host other than updates. Okay, hope you're with me so far. I keep over-explaining it and hoping that it'll sink in for those who have not had a lot of experience with these. If you've had experience with them, then I apologize, and this is a very basic system, so I'm sure you've got it. Let's talk a little bit about the host. And the host is usually a server, but it can be a PC or a laptop if it's a smaller system. I have seen systems with up to 60 access control doors on them run off a laptop. It can be done. A server is more robust. It's backed up. It's got redundant power normally to it. It's cared and fed differently, if you will. So it's normally a server. It's polled by the control panel every few seconds. Essentially, the control panel is jumping back up to the host saying, got anything new for me? Yes, no. Got anything new for me? Yes, no. Every couple seconds. It just keeps asking for any updates or changes because there's an administrator sitting there, and in a very active large system, they're making changes all the time. Brian used to be allowed in door number 1 and 2 and 4. Oh, now he's allowed in 1, 2, and 3 because we made a change. His job changed, or he needs access to it, but he doesn't need this one. Time of day changes, right? What time can Brian get in? We can reset all those things in our host. And every couple seconds, the control panel is asking the host, have you made any changes? Yes, no, have you? And if it did, it updates it. It's the interface for an administrator. That's where the administrator sits. You're not going to program anything directly into a card reader. You're not going to program anything directly into a field panel. You do it at the host. That's where the person sits and makes all the changes, right? you must have permission levels on a host. And the reason for that is that you don't want everybody who gets into this system. The systems are used for different things. The host remembers where you go to look up information. That history on who used the door is stored in the control panel, but if I want to go look it up, I'm going to look it up at the host. The host is going to ask the control panel, what do you got for me? Who went in this door? And it's going to show me on the screen at the host. You don't want everybody to be able to do that. You don't want everybody to be able to turn doors on and off for people, open and close doors remotely, right? You must have permission levels to control who can use certain features on your host. That's the place you do it. All of the permissions are granted at the host and then fed to the control panels. Back to our simple diagram. There you go. The host talks to the control panels. Control panels talk to the host. This is a two-way communication. This is one particular one's run by RS-485 communication lines. It can even be done wirelessly, though. You'll find systems that do that, and we'll talk a little bit about those. There are some vulnerabilities with wireless systems that still haven't been worked out, some frequency issues and other things that you won't see them as often as you might think. Even though everything else in the computing world has gone wireless, these systems tend to run off hardwired backbones or parallel to a information network that a company has running through their facility, but they tend to be hardwired systems. So what other components do we have besides our reader and our control panel and our host and our door hardware? Well, we have something called a request to exit device. And let's just move on to the next one. We have our locking devices, right? Electric strikes, mag locks. We studied those last week. You understand what they do, right? Either use a magnet or some type of electric lock to open and close the door. And then we have backup supply and backup power, just in case power is lost, so that we can still operate these systems even when power is lost, so people don't get locked in or locked out. Let's take a look at some of those systems. So let's first talk about this request to exit. Now, you went into the room, you used your badge, it went up to the control panel, said, yes, you can get in this door, sent the signal down, unlocked the door, and you went inside. The door now locked. You have to have a way to get out of the room. Now, in some cases, you can just use a crash bar on the inside and hit it and open the door, or turn the handle and pull the door open. There may be another reader on the inside that you have to use in order to get out. Or there could just be a REX, a request to exit. And this particular one is a push-button REX. So you go into the room, use your badge, says yes, go in, and the door unlocks, and you walk in, you do what you got to do in that room, and then you go to get out. In order to release the electric strike, or especially to release a mag lock, if there was one on this door, you would need to do something to release it. You push, in this case, this red button on the inside, and it releases the magnet so that you can open the door and get out. For every door that you get in, there has to be a way to get out. It does a couple of things, and we'll study these contacts right here. These are alarm contacts. So just in brief, when you use your badge and it says unlock the door and it sends it down, it does two things. It unlocks the door and then it shuts off this alarm so that when you open the door, you don't send alarm in to the guy who's sitting here monitoring the host who says somebody just forced this door open. It didn't happen. So it also shuts the alarm off. That REX device does two things. It releases the door latch from the inside. This is on the inside of the door. And it also then shuts the alarm off so that you don't cause an alarm when you're going out, because you're allowed to go out and you don't want to say that somebody's forcing the door. You're doing it perfectly legally. So the REX device is a request to exit. Push buttons are one way, and we'll look at another in a second. Control panels have a battery. There's usually a box that sits next to them. Sometimes the boxes have them internal to them. The batteries look, and I know I can say this to Western PA kids, right? They look like snowmobile batteries. And usually there's two of them. They will generally power the electric strike, the control panel, and the reader, and the REX for up to 4 hours, depending on the usage, right? Any battery, if you use it more, it's gonna last less time. But on a standard door, you can usually get about 4 hours of backup power. If the power from the host is lost and the power in your building that's controlling this, right? It's hooked to electric, right? It's low voltage, but it's hooked to an electric transformer. If that goes out, the lights go out, right? Power gets cut. It will run off battery and it will still record everything and it will still open and close the door. Now, when it's running off battery, obviously your host now is not running off of anything unless it's hooked to an emergency generator. So there's no polling going on. It's not getting any new information. It's acting off the information it has stored already. But that battery, they need to be changed annually, or at least tested annually. And they do. They look like little snowmobile batteries, usually two of them in a box. And it's really simple stuff. And then, of course, we have the electric strike here, or we have a mag lock on some doors. We've studied those before. So the REX, request to exit, often referred to as a REX for that very reason, can be a push button or other device. The batteries power this up in case the power goes out so that your door still operates, so you can still get in and out, not lock people out of areas that they need to get into in case of a power outage. Can you imagine if you have a card reader on your electric substation room, right, or electrical control room, and you need to go in and reset the power, but you can't get in because there's no power to the reader? This makes sure that the reader works and the door strike works for a limited amount of time. So I want to talk just a little bit more about REX devices, and the reason I want to do that is because in this class, in the past, the number one thing that was left off of doors when you needed them were REX devices. Now, it can be a push button. It can be built to the crash bar. You know, the crash bar is that long bar that you see that you use. They're called a crash bar, right? In case you need to crash out in an emergency, right? You hit the bar on the door. It can be an infrared dual technology. It works on both motion and heat, or one or the other. You can set them either way. But something has to tell that door that somebody's trying to leave in a proper way so that it will release normally the magnet. You can work around electric strikes other ways, but a magnet, if it's locked down from the outside so that people can't get in, it's also locked from the inside. And you need some way to release that door. And if you don't have a reader on the inside, which would be an expensive way to do it, and if you don't need to record who's leaving the room, you only want to record who went in, then you wouldn't want to make that expense. You have a REX device. But just think of it this way. If you don't have a REX device of some kind, there's not a way for you to tell the system, I want to leave the room. You're probably going to get locked in if it were a magnetic room, right? If it was on a mag lock. So you have to have some kind of REX device. Two kinds, the push button that we saw, and then the infrared REX device, which looks a lot like this. And you will see this over doors in commercial settings all the time. And basically, it just picks up your motion or the heat from your body, depending on which type of device you have or whether it's set for both. And it says, here comes a person. It sends the signal right back up to the control panel, isn't looking for card information. It's saying, I'm inside. So whoever is in here has already been cleared. You don't need to make a decision as to whether or not to let them in. Just unlock the door when this thing goes off so that somebody can exit and get out safely out of the room. A couple considerations when you're putting in an access control system that you won't have to do for your project for this term, but when you get into the real world, it's a big consideration. And that's what brand of access control system are you going to use. There are probably 24 types of commercial access control manufacturers out there, at least, if not more. And in fact, there's probably more. Some of them are rather large companies. Some of them are small. Each system does things a little differently. Each has its own nuances and does it in a different way. Some use proprietary cards where you have to buy your badges or your fobs from the same company. Others use a generic type that you can buy from anybody else. But the brand of the system, we're not going to decide that here, but you will. There are some that are very large. Linnell is a big system. Siemens is a big system. Secure, Johnson Controls, and ADT make their own system called AMAG is out there. I mean, but there are lots of brands. They all do things a little differently. And as a security manager, you're going to make decisions. Normally, you will inherit your system when you get to your first place of business. You have to determine who's going to administer that system. At some point, somebody's got to make that decision at the host. You can't just let this thing run on its own because, people leave the company, people turn in their badges, they no longer need access to some places, and someone has to administer the system. Is it going to be you? Is it going to be somebody in your staff? Is it going to be a guard in the lobby? Is it going to be a receptionist? That's a decision you need to make. Where to put the control panels, the field panels, if you will. I'll keep calling them control panels or controllers. That's a big decision because people tend to put them sometimes up in a false ceiling, but then in order to work on them, someone has to get on a ladder. Other people put them too close to the ground, and they put them on a wall in an area where they keep getting banged into by forklift operators and people moving heavy equipment and all kinds of things and do damage. Where you put them, you need to consider how high up on the wall you want to put it. I have seen people put these things 20 plus feet in the air so that they're safe from any physical damage. And then the batteries need to be changed, and they have to hire somebody with a scissor lift to get up there, and it costs them $1,000 to get the batteries changed, right? So there's some considerations there. But really the biggest consideration is it worth it? Do you need electronic access control? Does it match the risk? Do I need to know? Do I need a history of who went in and out of this area or this room or this building? That's the biggest consideration. If you need a history, then you need some kind of electronic access control. If you don't, If you don't require that history, you just want security on the room, a key may be your best bet. You have to consider data retention. How long are you going to retain this data, right? The more history you retain, the more space you're taking up in your host, the slower things are going to get. And then there's also considerations, as those in my law class understand, that you are responsible for that data and you have to protect it. Are you going to use that access system for other purposes? So if you're using electronic access control to get into the building, is that going to be your time clock? Sometimes that's a good idea. Sometimes it's not such a good idea because now you're also administering time cards, and is that the job the security manager wants to do? But that's a decision you make within your company, and then you have to set your system up so that reports go out on people to the payroll administrator so they know when people came in instead of punching a time clock. And then you have to consider how you are going to ensure egress in an emergency. Just as I said with that Rex device, what happens if it fails and there's a mag lock? There are a number of considerations, but the biggest one when it comes to electronic access control system, and the one thing, if you take nothing else away from this course, is that they have to be integrated with the fire system. Any access system has to allow for free egress. So with it, I guess there's a limited exception if we talk about that classroom security lock, where you're locking it from the inside as well, so people can't get out. But that's because the egress path is not at all safe, right? But any other system, you have to allow people to get out of a building, to get out of a room. You can't chain rooms shut. There are a number of horror stories about factories that chained emergency exits because people were going out those emergency exits to smoke cigarettes on their breaks, setting off alarms. And so they chained them shut and then had fires. You must allow for free egress, okay? If you use mag locks, they're particularly susceptible, and they have to be independently wired to your fire system. So if you have a mag lock on a door, two things happen when somebody pulls the fire alarm. The alarm goes off. Well, a couple things could happen, right? The alarm goes off. It could notify the fire department. The horn starts sounding in the building and people leave. It may trigger the sprinkler system, I guess. I'm not an expert on fire systems, but I do know that it also needs to release any mag locks in the building. It has to be independently wired to your security system. There has to be an interface between the fire system and the security system, that the electronic security access control system, that shuts the mag locks off if somebody pulls a fire alarm. A Rex alone, even though it could be the push button Rex, right, which releases power, that's exactly what it does. When you push that, it goes to the control panel, and then the control panel says, okay, release the power on the magnet, let them out. It does not meet fire egress laws. You have to have it independently hooked. Crash strikes can be mechanically connected to the crash bar, right? If you use an electric strike, maybe you have a crash bar on the door, or you could use a crash bar and hook it to the mag locks. Same thing. It still must be independently hooked to the fire system, so that the fire system has the last say about what gets locked and what doesn't get locked, because you cannot take the chance that your system will fail as part of that fire emergency, whatever it might be, and people get locked into a burning building. Just a quick word on new systems that are out there, and because we talked about the very basic access control system that's been out for the last 20 years and is still in existence today and is still used today and still installed today. So I really wanted to make sure that you just understood what the basic system looks like. But new systems are coming out that are wireless from the control panel to the host. So you don't have to run all that, or RS-485 cable we talked about from the host to every control panel, especially if you have them spread across a facility that may be many acres, right? A big giant warehouse. Ours in our project is going to be 100,000 square feet. I have individual buildings that are over 1 million square feet in my inventory. Can you imagine the amount of cabling that runs through ceilings just to work the access control system, let alone everything else in the building? So wireless systems are available. Readers can be wireless to the control panel. So you could have a wireless reader talking to the control panel and then a wireless control panel talking to the host. You really have no cabling between them. In long distances, they require a booster. Normally it's over 400 feet in run that you have to use a booster. But boosters can be an issue. I found, especially outside the U.S., many country laws don't allow you to use them because they're a radio signal, and you have to have a special radio license, and they have to have different frequencies set aside for it, and some countries haven't even done that yet. When you get into Eastern Europe, you get into parts of Asia, parts of Africa and the Middle East, they haven't set aside the frequencies for it, so they don't allow you to use the wireless. So they can be an issue. there are definite cost advantages. I mean, running cable through a building is a very expensive thing to do. There are companies that make billions of dollars just going to commercial buildings and running wiring and cabling through them for different projects. They are agnostic of what the project is. I need this type of cable run from this point to this point, and they go up in your ceiling and they run that cable, right? But there are definitely cost advantages, as you can imagine, with wireless because there's no cable. But there's also definite vulnerabilities. Power and signal loss being one, right? Wireless signals get interrupted a lot more often than wired ones. You know, how often when you were on your telephone, when it was wired back when you were a little kid, maybe even, well, maybe not for most of you, but for some of you, you had home telephones and they were wired home telephones and they seldom cut out, you seldom dropped a call. But even in 2021, when we hop on our wireless, devices, our cell phones, calls get dropped. I get calls dropped frequently, especially depending on where in the world I'm talking to, right? So there are definite vulnerabilities when you talk about any wireless system, including cybersecurity, because it is easier to intercept a wireless signal than it is to hack into a wired one. That's just common knowledge. So new systems, wireless tends to be something that's being pushed. I'm not a big proponent yet. I will be when it gets better, and I'm watching it every day. But you will see a lot of new systems that are wireless. So what do you need to know? In order to be successful in our project and in the course and going forward, you need to know the definitions of access control, both, right? Both the one we're using for the course, which is electronic access control, and then access control in general, locks and guards and receptionists and anything, signage that can limit people's movements is really access control. But you need to know both of those definitions. You need to know the components of the system. For us, it's the host, it's the control panel, it is the reader, it is the door strike, it is the Rex device, and that's all you really need to know. The locking device, that's all you really need to know at this point, and how those interact with each other. You need to understand what makes electronic access control unique compared to a key lock, and that generally is the history and the ability to turn off access remotely. Right? You don't have to go and find the person and get their key back physically from them. You can just turn the badge and access off in the host. It tells the control panel, don't let them in if they try to get in and they try to use that credential to get in, and it doesn't let them in. Understand the importance of permissions on that host. You don't want everybody to have access to everything in your system. Permissions need to be set at the host and permission levels to get into doors, right? If you're going to put a card reader on where anybody can get into that door, is it really the best thing to use? Understand why a Rex is important, right? You need to understand that when you get in, you have to have a way to get out. And if there's not a reader, if it's not required to read in and out, and you want to save that money, to do that, you have to have a way to disable the lock or open the door and to tell the system somebody on the inside who's legally here is getting out, open the door for them. That's where the Rex device comes in. And then, extremely important, emergency egress can never be impeded. You need to make sure that your access control system is physically integrated with your fire system in your commercial building so that if the fire system goes off, people don't get trapped in. The power to your devices automatically drops out and allows people free egress from rooms. So as you know, we're going to be applying everything we learned to the design of a physical security plan and essentially a physical security plan drawing for our Butler County warehouse. And if you have been keeping up and you've looked over the information on that, then you have a general idea what we're going to store in the warehouse and where it is and what its general use is at this point, right? We've talked generally about the risk and threat to that building. And you've seen the pictures from the outside and pictures from the inside. We're going to come back to the outside of the building. Don't worry about that. But right now, I'd like you to take a look at the floor plan inside, and that is in the documents in the D2L shell. And I'd like you to start thinking about the lock sets for the doors. Now, in this week's discussion, there is new information about what some of the rooms might be used for and what you might want to know about those rooms, right? That may impact what type of lock you put on those doors. This week, you're going to start your first markup of those drawings. There is just very specific instructions in the discussion about how to mark up your drawings. You're going to do the first markups of lock sets and electronic lock sets in our warehouse building. I don't expect perfection. I expect a lot of mistakes. You should too. Just know that you're going to have to redo things as you go along and learn more. You'll say, oh, I decided that in week 6, but now that we're in week 8 and I know something different, maybe I'm going to change it. Just understand that that's part of the game here. It's not too hard to redo those drawings once you've done them, but if you can do them and you don't make many changes and you keep them neat, you won't have to redo them very often, right? You're just going to add to them as we go along. You're going to turn in your marked up drawings per the discussion, then you're going to comment on differences that you have with others, because no two drawings are probably going to be exactly alike. Someone's going to put a particular type of lock on. I know which room it's going to be, that everybody's going to have a different type of lock on. And then I want you to discuss why you decided to put the type that you put on a particular room when someone questions it. Why did you put a office lock on this room when I put a passage set? Well, I thought this might happen, that might happen. And you can say, well, yeah, I either buy that or I don't. But I want you to comment on the differences with others. Make sure you have an idea what's being stored or done in the room. That's the big kick. You have to protect what you're protecting, right? You have to understand what it is. So we know what's going in our warehouse. I give you new information about the file room. The other rooms are offices and conference rooms and break rooms. I think those are pretty self-explanatory, but if you need more information, certainly ask. But make sure you understand what's being secured when you determine what type of lock you're going to put on that door. One more point on that last slide. Please don't say you're going to put mortise locks on the doors, because what I'm looking for is function. A mortise lock, as we know, can be set to different functions. And if you say it's a mortise lock, you're going to need to tell me the functions. I'm really looking for the function of the lock, and the different codes and the different types of locks are listed in the discussion. Use those, please. So you're going to read the text, chapter 7, pages 97 through 108. There's an article. It is a commercial article. As you know, I use a lot of commercial articles. They are by people who are trying to sell you something. I'm not trying to sell you on anything. Please don't think that, but some of the best literature on, especially when it comes to electronic security and physical security, comes from the people who sell it, because they have to convince you why it's a good idea or what's good about their products. And so it's a commercial article, but it's a pretty good one. Make sure you print out the slides for the lecture, and you've just completed the lecture. Your drawing needs to be submitted by Thursday, and respond with an N in there, to others by Sunday. Thursday, 11:59 p.m. is the latest you may submit this set of drawings. And Sunday, 11:59 is the latest you may make responses and comments on the drawings of others. We do that so that others have the opportunity to look at your drawing to make comments on it. If everybody submits at 11:30 on Sunday night, there's no time for anybody to decipher anything and make any comments. If you don't turn it in by Thursday at 11:59 p.m., go ahead and take your 0, and you can wait and turn it in at your leisure. You'll need to turn it in at some point, because we're going to just grow from this drawing and add more things to it. So I'll see it later anyway. Why not get credit for it and get it done by Thursday? I also want you to look around. I know that people aren't really traveling much now, but look around campus, look around other places that you may go if you're not on campus, and look for access control devices. See if you can find different types. Are they swipe? Are they proximity? How do people get into these places? What's your thought about that? If you are somewhere, look up above the door. If you see something, if you're in a facility that may have some type of access control on it, look up above the door when you're leaving. Is there a REX device of some kind? And if not, I wonder how they're working that, right? It'd be interesting to find out. But look around and start looking for things like access control systems and different types of door locks. I want you to become familiar with them to the point where as soon as you put your hand on something, you understand exactly what it is, right? So be observant of your surroundings and start to think about physical security on these doors. With that, have a great week. I will be around if you need to talk to me, and we will probably talk during the week. I will be live on office hours Wednesday night from 6 to 7 for this and my other class. Office hours are 6 to 8 on Wednesday. And of course, don't be hamstrung by the office hours. I'll talk to you guys anytime, as long as I'm awake, right? But I will be on from 6 to 7 on Wednesday. If you just want to drop by and say hello, or if you have a question about something, that's a good time to ask it. I'll be here, probably grading discussions. So hope to see you then if you have questions. With that, have a great week.